For centuries, Isaac Newton grounded our reality in absolute equilibrium and causality. But Albert Einstein replaced this mechanical truth with the illusion of a curved space-time continuum. Force is the absolute foundation of our reality. In classical mechanics, Isaac Newton understood this ultimate truth, anchoring the universe in perfect mechanical equilibrium. Yet, modern physics erased this foundation. Maxwell, Schrödinger, Dirac, and Einstein stripped force from their equations ghost without substance.
Welcome to a new Tensor presentation. Today, we confront the ultimate question of continuous equilibrium in physics.
In 1865, a fatal abstraction took hold. Light was reduced to a mathematical ghost, without mass and without force. Break the illusion. We lost the physical foundation of our universe to 150 years of incomprehensible dogma. It is time to break the illusion. Two giants of physics, two conflicting realities. Newton anchored our universe in an inflexible equilibrium, where action strictly equals reaction.
Albert Einstein, however, abandoned this rigid mechanical equilibrium. His space-time is not a motionless stage, but a flexible continuum that curves and bends to accommodate mass and energy. But this illusion was a forced choice. By erasing force density, Maxwell destroyed the physical medium. To explain the constant speed of light, Einstein had no other option. Space itself had to bend.
But this illusion was born from a fatal misinterpretation. In the Michelson-Morley experiment, light travels back and forth. Because of this round trip, the influence of the observer's speed becomes so small that electromagnetic interaction, an effect completely ignored by Maxwell, creates an outcome that has been interpreted as a constant speed of light. The constant speed of light was the rock upon which Albert Einstein built his theory of general relativity. But how solid is that rock? How constant is the speed of light? When we look at a laser beam, the forward speed equals c, but the sideways speed equals 0. If the speed of light is a universal constant in every direction, how can it equal c in the direction of propagation and 0 in the cross directions? We know that light is an electromagnetic wave. Low-frequency radio waves propagate in every direction at the speed of light. What makes the difference between a radio wave and a laser beam? It depends on the wavelength. The shorter the wavelength and the higher the frequency, the easier it becomes to build a resonance cavity. This brings the electromagnetic wave into resonance, making use of the exact effect that Maxwell ignored completely: electromagnetic interaction. Only through electromagnetic interaction is it possible to lock up the light in the cross directions and let it propagate forward with the speed of light. Have you ever wondered why a slide projected on a screen does not move? Why it does not explode outward at the speed of light? That is because of electromagnetic interaction. Electromagnetic interaction dictates the velocity of the electromagnetic wave. When you watch a movie in a cinema, you are constantly watching electromagnetic interaction in action. The fact that we see it every day results in the fact that we don't see it anymore. James Clerk Maxwell was a brilliant mathematician with a profound insight into physics. He was the first to realize that we must connect electric and magnetic fields to truly understand the majesty and unity of light. He derived the value for the speed of light through pure mathematical calculations. But despite his brilliance, he did not realize that something crucial was missing. He did not understand why the speed of light had exactly that value. And he could not have known. We had to wait for Albert Einstein's famous equation, E equals mc squared, to finally understand the reason. It is the inertia of electromagnetic energy that controls the speed of light. Without this inertia, radiation pressure would push light forward at an infinite speed. It is the perfect equilibrium between radiation pressure and the inertia of electromagnetic energy that dictates this constant. Exactly where these two forces counterbalance establishes the exact speed of light. In our search for this fundamental truth, we find Newton's second law of motion once again. Einstein spent his entire life searching for the physical reason behind the speed of light, but he never found the answer. It was as if he spent his life searching for the philosopher's stone, while the stone sat right in front of him in a locked box. He was holding the key, E equals mc squared, in his own hand, yet he did not know how to open it. Looking for wisdom, he eventually became lost in an infinite, curved space-time continuum. In truth, he and Newton together were the only ones who possessed the power to open the box. If the speed of light is controlled by a perfect equilibrium between radiation pressure and electromagnetic inertia, there is no reason for it to be a universal constant. If we increase the electromagnetic mass while keeping the radiation pressure constant, the speed of light must slow down. Has this ever been measured? Yes. This exact effect was demonstrated by physicist Lene Hau and her team at Harvard University using a Bose-Einstein condensate at extremely low temperatures. Hau cooled a tiny cloud of sodium atoms to a fraction of a degree above absolute zero. When a laser pulse entered this super-cold, dense cloud, its frequency resonated with the atomic dipoles. The electromagnetic mass of the laser pulse coupled with the mass of the dipoles, increasing the total electromagnetic inertia considerably. The radiation pressure did not change, but the mass increased. A new equilibrium was established at a drastically lower velocity. The heavy interaction between the light and the matter forced the beam to crawl. In 1999, Hau successfully slowed a pulse of light to just 17 meters per second, roughly the speed of a fast bicycle. And later, in 2001, she achieved the impossible, bringing light to a complete and absolute stop inside the condensate. Lene Hau broke the rock of a constant speed of light, upon which Albert Einstein had carefully built his theories of relativity. If Maxwell is unable to describe a laser beam, and Einstein's absolute foundation has fallen, a fundamental question remains: how do we go further? The answer is, we must go back to the master. Not Einstein, but his teacher, Hermann Minkowski. Minkowski created the mathematical box containing the philosopher's stone. In 1908, he revolutionized modern physics by introducing the four-dimensional space-time continuum. He combined three-dimensional space and one-dimensional time into a single, unified entity. He defined the time coordinate as the speed of light multiplied by time, giving time the exact same spatial dimension as length. Minkowski proved that the Lorentz transformations were not merely algebraic tricks used to calculate how moving clocks slow down or moving rods shorten. He reinterpreted these effects as real, geometric, hyperbolic rotations in 4 dimensions. But Einstein took this 4-dimensional box and never truly opened it. All we have to do to open Minkowski's 4-dimensional box is to elevate Maxwell's decrees of divergence-free electric and magnetic fields into a 4-dimensional, divergence-free Minkowski stress-energy tensor. And by using E equals mc squared, we can finally express the divergence of electromagnetic energy as the true origin of gravity. To complete this framework, we formulate the Minkowski-Maxwell equation. Hermann Minkowski's monumental contributions are vastly underappreciated. By taking the divergence of his 4-dimensional stress-energy tensor in the spatial domain, we achieve what Maxwell's original work could not. We define a perfect force-density equilibrium, measured strictly in newtons per cubic meter. This expresses the exact electromagnetic confinement of a laser beam, maintaining perfect equilibrium in both the forward direction of propagation and the transverse direction. By incorporating the four-dimensional gravity tensor, the Minkowski-Einstein field equation is born. Through Einstein's principle, E equals mc squared, the divergence of electromagnetic energy reveals the true origin of the gravitational field. Just like Einstein's original field equations, this framework elegantly explains gravitational redshift, but it removes the ultimate barrier to the truth. The fundamental advantage of the Minkowski-Einstein field equations is that they are not pinned to the false assumption of a constant speed of light. Instead, these equations perfectly predict the dramatic deceleration of light in Lene Hau's experiment, as well as the electromagnetic lock-up effect in photonic crystals. We have finally restored true equilibrium to theoretical physics.